Welcome everybody to this webinar on renovating historic buildings towards zero energy. I'm happy to inform you that we have more than 100 participants. My name is Tove Råström. I'm a professor in building conservation at Uppsala University, and I'm also the scientific coordinator of the Swedish National Research Program on Energy Efficiency in Historic Buildings. The project that we're about to get presented is part of the International Energy Agency Solar Heating and Cooling Program called Task 59. And the webinar as such has been sponsored by the Swedish Energy Agency within the National Research Program on Energy Efficiency in Historic Buildings. We have a rather solid program today with 5 presentations of the outcome of the project. We have decided to keep it relatively short, so there will be short presentations, meaning that at the end of the day, you will hopefully have been informed, but possibly not educated about all the aspects of the program. And therefore, I would like already now to point out, if you look above my head, you will see a link that brings you to the webpage of Task 59. And if you click on results, you will see the reports reflecting the outcomes that are presented today. Today, you will see 5 persons who have made important contributions, but I also would like to thank all the other persons who made contributions to the project. This has been a big project with contributions from many persons from many countries. Now, last information before we get going with the actual presentations is to you who are listening. If you have any questions, please put them on the chat. We have a few minutes in between each presentation for questions. If we don't have time for your questions at that time, we will try to get back to you at a later stage. After the last presentation, we will have about 15 minutes for further questions and discussions, and we're aiming to end the webinar at 5 o'clock. With this, I would like to introduce the first speaker. This is the project leader, Alexandra Troy from URAC Research, and she will give a presentation of the project as a whole. The screen is yours, Alexandra.
Thank you very much, Tor, for the kind introduction. Let me immediately dive into the presentation. I would like to just give you the first overview on to kind of define the frame of what comes afterwards. Renovating historic buildings towards zero carbon. I would like to start with this image, showing a bit with this that there is a need. This is a photo of Bologna, and you see that in Bologna, quite a bit of the buildings have a historic background. They might by far not be all protected, but all of them include elements, include characteristics which we would like to keep. And at the same time, we know that we have to drastically reduce CO2 emissions. So actually, there is a need to find good solutions. If we consider, just to have a rough number of how many buildings is it negligible or not? If we just take the buildings built before 1919 or before 1945, and with this, I do not want to say that new buildings would not have heritage elements. But as a rough number, you would see that this is 1/4 of European building stock, and 55 million of dwellings and 120 million Europeans living in them. Now, if we see what is going on in the very last time, I would like to cite 2 people. Frans Timmermans on the one hand side, who said that one of the greatest challenges the continent faces is converting the historic buildings in Europe's centuries-old cities for a sustainable future. And Ursula von der Leyen answering on that more or less, that by saying we will set up a new European Bauhaus, a co-creation space where architects, artists, students, engineers, designers work together to make that happen. So I definitely see a need, and we saw that need also quite some years ago. Actually, there was the question, is this a task for the IEA technology cooperation programs? What are these cooperation programs? So IEA stands for International Energy Agency. And the technology cooperation programs are programs where experts from different countries, different nations collaborate on specific topics. There is, for example, one on solar heating, cooling, one on energy in buildings and communities, and many more. They have representatives of each country in the so-called EXCO, and it actually was the EXCO of the solar heating and cooling program who initiated the task definition phase on a project on energy retrofit of historic buildings in 2016. I gathered a team of experts, and actually in 2017 we were ready to start. How do these tasks of the International Energy Agency work? It is not a project like a European project or a national project where you have a budget and you work on that budget. You work with experts. You look for experts in the different countries who could contribute, and they are usually financed by their country or financed by projects that are running. So what you see here is the logos of all the contributing partners. We started with a little bit smaller group, but this is what the group at the end. You see at the right, projects where we took information out, brought together, and it's not complete because it is the project we had at the beginning. We had some more. We had the Interreg Atlas project. We had the Interreg BIPV Meets History project. We had the Belgium National Peer Renewal project, and many others. And we finally, you can see here, where 46 experts from overall 13 countries in 25 different institutions who are contributing. You can imagine that the meetings we had twice a year were quite big meetings, but we all appreciated this bringing together a lot of knowledge. When we were in the task definition phase and thinking about how do we want to approach, what are the single experiences, there was a discussion starting on how do we interpret the title? Would it be reducing energy demand to a close to NZEB standard, but this with a focus on preserving as much as possible of the building's historic aesthetic value? Or is it rather we want to reduce the energy demand as much as possible while preserving all the building's historic and aesthetic values? We finally decided that this is not the crucial question, but that the crucial question is that we find a way to enhance the dialogue, because the dialogue is what helps us finding the good solutions. This is something where we very easily could agree upon. And what we also could agree upon is that we want to look at it as a holistic approach, that it should be always looking at both sides, reducing the demand and providing what is missing from sustainable sources. You see the building on the right with a lot of circles showing where you can intervene on the energy performance of a building, and actually also thinking in solar, since we started from the solar heating and cooling program. There is different kinds of solar. There is passive, active, solar thermal, photovoltaics, hybrid solutions. And maybe I missed to mention that solar heating and cooling program initiated the task definition phase, but actually also energy in buildings and communities stepped in. So the national experts who contributed came from countries of both these programs. Whom did we finally want to address? We wanted to really come to the ground, to make it happen. So our target audience were the architects and the consultants working on historic buildings, working on energy retrofit, the building owners themselves also, because they are the ones who finally have the decision, who finally have to be convinced that it is a good thing. The heritage authorities to take them in the boat And then, of course, also developers, contractors, policymakers. We decided to structure the work in 4 different subtasks, where then the national experts decided where to contribute most. First, thinking about bringing together a knowledge base. What is there? What good experience do we have? What can we learn from? Then, based on that, specifically look into the multidisciplinary planning process. And on the other hand side, also look at the conservation compatible retrofit solutions. Finally, in the last task, we have concentrated everything which is about demonstration, dissemination, talking to people, bringing the results out, and also getting input in, not to forget. This is also how the presentations today are structured. So we will have Danielle talking about the knowledge base, Gustav about the multidisciplinary planning process, Rainer about conservation compatible retrofit solution, and Roger about dissemination and demonstration. And before I give over to the next speaker, I would like just to introduce one source of information which you might have a look at, because this is kind of overarching. It's the first paper we wrote together as a group, or as a considerable part of the group, where we looked at and identified the barriers to energy retrofits in historic buildings. We tried finally to look at what does lowest possible energy demand mean, and we came up with an idea, with a definition of this is finally a negotiation space. This is something which opens up if you understand well what the specificities of the building are and how you can answer to those with a tailored energy retrofit proposal. Then we were looking at how we could address barriers in engagement through best practice, and how we can address barriers in the planning process through guidelines. This was the first paper we wrote together as a group. There were quite some more, and you find them uploaded also in the resources part of the Task 59 website. There are still some more to come up, both journal papers and the papers of the conference we had in April, but I think this is something which Roger will be talking about at the very end. With this, I would close and hope that you get quite a bit of an insight idea on what all these national experts have brought together in the last 4 years.
Thank you, Alexandra, for this presentation of the project as a whole. As far as I can see, we have not received any questions yet. So I would really encourage you who are listening to use this opportunity to provide us with questions and possibly feedback on the work we've done. Also, it was pointed out that the link that you can see above my head might give you some troubles if you type in the 3 W's first. So if one way to make it work better is just leave out the W's and start with task59.iea/shc.org. So one of the most common questions that I get over the years working with energy efficiency in historic buildings is, show us some good examples. And it's easier said than done. So the HYBER Atlas, a best practice database, is potentially an important tool in that direction. So with that, I leave the screen, the virtual floor, to Daniel Herrera from UREC Research.
Thank you, Tor. Thank you for the introduction. And thank you very much for organizing this webinar. It's really nice to see that we have managed to attract the attention of so many people interested in the work we've done in the task and eventually interested in the energy renovation of historic buildings. So I will directly share my screen so you can already see the slides of my presentation. And as Tor was mentioning, the work I'm presenting here is the result on knowledge-based collection and the idea of building a repository or a database for best practice renovation of historic buildings. We started with the idea that some of the barriers that were preventing people from renovating their own historic buildings, and whether this is a private owned building or a public building, is a lack of trust, uncertainty or doubts in the process. But at the same time, we knew that there are very good examples already out there that could help to inspire others and to show what is possible. So not necessarily translate one solution in one building to another, because that is, of course, difficult in the case of historic buildings, but definitely inspiring and learning from the process. So with that idea in mind of trying to overcome some of the barriers that were preventing people from renovating historic buildings, we started working on this collection of good practices with the idea of trigger energy efficient renovations. Just very briefly, because it's overlapping with what Alexander just shown, just a reminder of why historic buildings and what we mean by historic buildings. This is an old postcard from Bolzano, where I'm sitting at the moment in the north of Italy from 1913. And if you go to the same part of the city or the town, you would see that it actually hasn't changed too much. The picture has more resolution, but the buildings are actually more or less the same. So this is just to illustrate that it changes across Europe at roughly 1/4 of the total building stock. It was built before the Second World War and has some heritage values, but for sure shares some traditional construction methods that need to be addressed in a certain way. And when we put all that together and we talk about energy retrofit, it's also about the scale. It is one thing when you look at a small town like Bolzano, but if you start looking at bigger cities like Paris and you bring all of it together, the result is that retrofitting historic buildings can potentially lead up to an energy saving of 180 megatons of CO2 per year. And that would help us bring us closer to the goals of reducing energy consumption and CO2 emissions towards 2050. Sorry, that went too far. So with the two concepts of historic buildings, not limited to listed, and energy retrofit to bring closer to the energy goals, we came up with this retrofit, and that's what the HYRA Atlas stands for, is the Historic Buildings Energy Retrofit Atlas, a best practice database to trigger renovation among building owners. And once again, historic buildings, what exactly means? We are basing our definition on what the European Standard 16883 already defined. So there was no need to redefine it. And this is all buildings that have elements worthy of preservation. That means buildings of all types, of all ages, whether they are listed, protected or not, anything that is worth preserving that we want to keep in our cities, in our towns, and work towards its conservation in time. So just a very small and brief snapshot of what the buildings that the historic database at the moment includes. You can see that it brings buildings from back to 1600 up to 1960s. So it really covers all sort of ages, but also all sort of construction technologies and building times. So you can see an old wooden building, an old farmhouse, but also a steel iron cast market in central Spain, or an industrialized building in Denmark. So there is no limitation in the age or typology, which brings some limitations on how you compare solutions across buildings, but it also shows the potential for energy saving in all historic buildings, independent on how they were first designed and built. Now, in here, I will be showing some of the screenshots of the actual website. I will show the real website in the end, but this helps us, or helps me presenting or guiding the presentation in some topics that I was interested in discussing. And the first of all is what is documented and how we define best practice. So the first, the basic 5 points that we have used to define best practice and to accept buildings being included in the process is that should be cases where the implementation of the project was completed. We didn't want to base our best practice repository on theoretical cases, because we are well aware that most of the limitations in renovating historic buildings arise during the implementation phase. So what happens when you actually have to bring this projects into practice. So we all have only included projects where the renovations have been implemented. And they should consider the building as a whole. It's not just about replacing windows. It's not just about insulating one wall. It should be interventions where the whole building has been considered or studied. It doesn't mean that every single element of the building has been renovated, but the building has been studied or considered as in integrity. As Alexander was mentioning earlier, setting a benchmark for historic buildings in terms of energy demand or energy use, it doesn't make sense. So what we wanted is to have significant reduction of the energy consumption and going towards the lowest possible energy demand. So in that respect, we kept the same definitions in the database, and we included buildings or any building that has worked towards this lowest possible energy demand. And by all means, only buildings where the heritage compatibility was also put at front of the renovation process. We, as a group, I think we all agreed that nobody wanted to reduce energy demand while or at the cost of losing some heritage aspects of the building. So only cases where the heritage compatibility has been very well studied and evaluated are included in the database. And because we want people to use these cases to get inspired, but also to get some guidance on what is possible to do in historic buildings, we have included buildings where extensive documentation of the process was available. And we will see that in a second when going through one of the cases. So we had a fairly basic landing page, where you have the thumbnails of all the buildings, and then by clicking one of them, you just get directly into the basic information, summary information of that building. Because the target audience we are addressing is quite varied, it goes from a private building owner to an architect or even a policymaker, the heritage authority of a municipality of a region. We wanted to work with and present different levels of information, different layers of information. And we have presented that in that way, in different layers. So when you first access one of these case studies, you see a very short summary of the project, in this case, just one paragraph, a short menu on top of this horizontal bar that gives some key facts about the building and some small pictures and plans about the building. As you click on the more buttons, the information is extended, and the depth of the information and technicality of this information is also extended. With this way, you can just browse from the basic information on the top of the page, scroll down the page to get more elaborated information, and extend even further into more technical details. So depending on what your interest is at the moment, you can find the different information. So by clicking on all these plus or more buttons, you see that every step along the way, it is, or every set of information is extended. For instance, if we look at the as first option, or the energy performance, there is one key factor that summarizes, or key fact that summarizes the energy performance, the kilowatt hour per square meter a year. But that doesn't tell you the whole story. You also need to know what the climatic conditions are, what the altitude, location, and so on. And that is just an example that I think you would repeat throughout the project and throughout all the projects. A second step in the information that is presented for the renovation of each case study is a description of the context and the rationale behind the solutions adopted. So it's not only about listing the technologies that were implemented, but rather telling a story on why the renovation was carried in that way. Historic buildings are all different and all to be considered separately. And what can be shared across case studies is the thinking behind. So what were the challenges faced, what were the conservation issues found in that case, and how the solutions identified were defined eventually. So it is important to start with a detailed description of how the building was from a typology construction point of view, but also the conservation status. And then if you click on further information, you find detailed information about the heritage significance, how the definition of the elements that were worth of preservation were defined, how the interaction with the local heritage authority was. So you find more detailed information on the rationale behind of all this information. It even comes to the point that it discussed the condition of the envelope in terms of conservation, but also a brief description of the building services that were found in the building before the intervention. That also helps understanding the justification for why they replaced a boiler in that particular case or whatnot. The next section in the description of the case studies goes into the technical solutions. And again, we replicate the idea of a first basic level of information where you just have some pictures, a description in 2 paragraphs, and the basic values that summarize this case. So for instance, we're looking first at the external walls, and you have the view value pre-intervention and the view value post-intervention. You see on top that you can change between the different wall types that you could find in the building, and that is adapted to every single case study. If you then click on the more section, you'll see that this menu extends, and you see a graph that summarizes the wall buildup and is made automatically for all the wall solutions that you find in the website, and gives a bit more detailed idea of how the wall before and after the intervention was looking. Then the similar approach repeats for the windows, where we have a description, the U value of the glass frame, and all the information about the glazing type, and also information about the roof, the ground floor, and measures to increase the airtightness of the building. And the last part of the documentation of a case study is about the evaluation. So we have started from the description of the building, why the renovation was needed, how the renovation was implemented, and discussed with the heritage authorities, the single solutions that were eventually implemented. And what we wanted to show in the end is how well that intervention has worked out. So we have an evaluation section that is defined in four different sections, looking at the energy efficiency aspects, costs, internal climate, and environment. And in this case, because we assume it's a quite detailed information, there is no summary. So as you're interested in any of these aspects, you can click on the arrows, and then the information are more detailed. And where available, it also links directly to the reports or technical information or monitor data that is available for that particular case. For instance, in the energy use, under the heating section, you see there is a link to a PDF, and by clicking that, you download a PDF that is the calculation for the space heating demand based on the local energy agency protocol that have implemented here in South Tyrol. Since the very beginning, we had the aim of building a large database, so not just 5-10 best practices, but something that was going towards the 100, and even more, that the project will stay alive after the end of the project, so that we were looking at a large database. And because of that, we wanted to be able to filter the cases so you could find something that were relevant, case studies that were relevant to your own needs, to your own building, or to your own case study. So the idea was to filter the case studies according to geographical area, building use, construction period, and so on. This image that you see has actually changed a bit in the last version, so I will show you later on how it looks actually on the website right now. But yeah, the idea is to filter according to certain predefined tags, filter by age, construction period, and so on, but also to show them all in a map, so you could also browse for buildings around your area. So this is a product, a tool that comes out of a research project. So it was developed actually as a joint development between 2 different projects, the Task 59, that is the topic of the day, but also an Interreg Alpine Space project called Atlas. And between the 2 projects, the development of the website and the documentation of the first case studies was done jointly. Initially, the first 57 case studies that you will find now on the website have been documented by partners of either of these projects. There are still some in the pipeline that will be finalized and hopefully being made available in the next weeks. But this will be the end of the research projects, hopefully not the end of the database. What we want now that the product is completed and we have tested thoroughly, and we are quite confident that it works well, is that now building owners, designers, practitioners, architects, and so on use this platform to share their own experiences and to share their own projects of best practice renovation of historic buildings. So now it would be up to everybody to continue enlarging this database. So if you know a good example, if you have worked in a good example and you want to document it, you can directly log into the website and do it all by yourself, or just get in touch with us and we will help you in the process, although it should be fairly self-explanatory in the website and so on. So now we'll just quickly jump to the website. So you see that it actually exists already, that it works, and it should hopefully, and I cross my fingers for that to work well. You shouldn't find any major bug. In any case, if you find anything, please just get in touch with us and we will fix it as fast as we can. So you can see that you can browse through all these 57 case studies. The one I was showing in my slides is this Weinhof, that it was the first one we documented, and now it's at the bottom of the website. And on the left-hand side, you have this search menu, and it has changed a bit. So you have the free search field, so you can just type any term, and they will filter through the project through that. So I could type Weinhof, as I know the name of the project, it will take me directly there. Or you can also use the filter function. So whether you're interested in looking at buildings that are only listed or not in a particular country, or with a particular technology implemented, you can just apply it here. Or as mentioned before, you can just directly browse in the maps for the projects. I just looked for Weinhof, so this is still the only project that is showing me. I'm, as I said, currently sitting in Bolzano in the Alps, very close to the Dolomites, and this is the case study, the first case study we documented the Weinhof in the very core of the Alps. So I'll go back to my slide just to conclude. To thank you, Tor, for the opportunity to present the Hybrid Atlas, and I'll be happy to answer any question that the audience may have.
Thank you for the presentation, Daniel. Yes, we do have some questions, and actually the first question was submitted right after Alexander's presentation, and the question reads, how useful do you see building renovation passports in the path towards near zero energy buildings? And what are the measurement criteria you see as being critical to the building renovation passport process? So I leave it to you, Alexandra, to at least begin answering that question.
I would say it's super interesting. These passports, I think, guide you through a step-by-step process, but they do it in a way that you start at the beginning with understanding the building and define what you will do over a long period, step by step, so that each of the parts play well together. We discussed that also in the task, and actually the Dutch experts had a nice term for it. They call this approach a not regret approach. As regards to your question on the key measurements one would look at, I would not go into detail here. I think in Gustav's presentation, which is the next one, you will hear about the standard and about the key performance indicators which have been developed there. I think these could be the ones, because in the case of the historic buildings, you would, yes, look at energy maybe also from a life cycle point of view, but not only, you would also have compatibility criteria and heritage impact criteria. Then actually your question started also a bit of discussion in the chat among us presenters here. Should I mention Gustav's comment or? Gustav,
yeah, please.
He just pointed out that finally as far as he knows, it would also be combined with a digital repository of information of the individual building, which I think is really a good idea, especially for historic buildings, to keep track on such a digital repository. With this, I give back to Tor.
Thank you, Alexandra. We have two more questions. The first is a short one for you, Daniel. Is this atlas only for Alpine architecture?
No, not at all. It's the Task 59 is a global project. We had American partners, and as such, that the database should also be global. There is a strong focus on Alpine architecture at the moment because the partner project, Atlas, was a project from the Alpine space. So the case studies, the buildings that our colleagues in Atlas documented, are all from the Alpine space. So at the moment, there's more weight on those buildings, but no, not at all. There should be, and hopefully it will grow in all directions, not only in Alpine architecture.
Thank you, Daniel. One more question. is the evaluation of insulation efficiency done at the end of a renovation project or a few years later when things might have happened to the quality of the insulation?
Mm-hmm. Let me start saying that we have tried to make a very detailed structure, but at the same time trying to give freedom to whoever documents a project to include the information that the author considers relevant. So we are asking for first, say, theoretical energy efficiency improvement thanks to the insulation. So yeah, the insulation right after the improvement right after the conclusion of the project. But there is for sure room to include information about any bad experience that can be improved, let's say. And that was an important part of the discussion at the beginning of the project, whether we wanted to show best and worst experiences or practices to learn from. But in the end, we wanted to focus on the positive. It doesn't mean that it neglects the things that might have gone wrong. So these lessons learned. So I would say you will find that in some cases, definitely not in every case, mainly because there is no information or the information is not particularly relevant.
Thank you, Daniel. That's all the questions we have so far. And having looked at best practice, good examples, one might be tempted to move on to solutions. But one of the sort of fundamental things about this project is that we wanted to facilitate informed decisions by systematic thinking and doing one thing at a time, which leads us to the next presentation, which is about planning energy retrofits of historic buildings, the European guidelines in practice. Gustav Leijonhufvud, Uppsala University, will make this presentation. Go ahead, Gustav.
So thank you very much. I will talk about the process and not on the outcomes. There was a European standard accepted in 2017. So it's been out there for a while, and our project started the same year. So it was a natural starting point for this part of the project. So the challenges that was important for the development of this standard, but also for our project are several. The first one is related to the legislation of historic buildings, where existing policies often are of an either-or basis. So you have listed buildings and non-listed buildings. But as Alexandra pointed out in the beginning, we have heritage values in most buildings, and not only in the listed buildings. Existing policies for energy efficiency have often exempted the listed buildings from demands on energy efficiency, and this has led to two problems. The first one is that we don't use the potential of energy efficiency in listed buildings because we don't do anything with these buildings because they are protected. And on the other hand, in non-listed buildings, we tend to do too much. So heritage values are lost, and we don't pay enough respect to the traditional materials and constructions, and we can get into trouble when it comes to technical issues such as moisture risks. So how can we solve this? Well, we have to deal with the buildings on a case-to-case basis. We cannot have universal solutions. but we think what we can have as a universal solution is related to the decision process. So we think that systematic and interdisciplinary planning processes will facilitate good decisions for the individual building. And we also think that we need to integrate energy conservation and heritage conservation. We cannot keep these two as two separated tracks in the planning process. So they have to be integrated. And this was also the logic behind the European standard, which is called Conservation of Cultural Heritage Guidelines for Improving the Energy Performance of Historic Buildings. So this is a standard that is supposed to be applied to all kinds of historic buildings. And we know that these are very diverse in terms of heritage values, in terms of use, in terms of construction, and so on. So the standard is like a roadmap for the decision-making process, which is supposed to be applicable for all buildings, from the small shed to the big monumental building. So essentially the standard is based on these steps. So first we have the initiation of the planning process with establishing the context. Then we have a thorough building survey, and that is not only the technical survey of the building, including the energy performance, but also about the use of the building, and of course the heritage values. Then there is a step that is often not so explicit, but in the standard this is really a core step, that is to specify the objectives. So what do we want to achieve with the renovation process? And here we also have these criteria that Alexandra mentioned. So it's 7 criteria in the standard, but the main ones are energy performance, heritage values, and the use of the building, and of course also the technical compatibility. So after that, it's the assessment and the selection of measures, and that is supposed to be a step where you look at many different possible measures, and then use the building survey and your objectives and identify the most relevant ones, and then you assess these ones in detail, and finally you choose a package of individual measures. So that is the core of the standard. So in our project, Task 59, we have evaluated how the standard works in practice. So we have used case studies where practitioners have applied the standards in real projects. And we have also talked with experts in the field about what they see as strengths and weaknesses in the standard. So the results from the evaluation is rather positive regarding the scope, the general scope and ideas in the standard. So users have said that it offers a systematic approach, where energy and heritage are integrated in a good way. The overall procedure suggested by the standard makes sense, and in general, the standard can function as a platform for disciplinary integration. So, as a platform for this dialogue that Alexandra mentioned. But users have had problems with understanding, with interpreting the standard. So there has been a lot of uncertainty about how to carry out the different steps suggested in the standard. It's also the case that the scope of the standard is the planning process. And there are already established processes for the planning of renovation of buildings, and there has been a lot of uncertainty of how the standard can be integrated into already existing processes. There's also been complaints about that the standard is lacking examples of how to carry out things. So the outcome of this evaluation is that we have identified that we need complementary and easily accessible information for users of the standard in order to get the full value of the standard. And that is examples of how the steps in the standard can be carried out. Examples of how the standard can be integrated with existing standards and procedures. Examples of energy retrofits and energy efficiency measures. Examples showing the benefit of following the standard. And finally, additional information complementing the standard, resources, literature, and tools. And we have worked in the project with these identified areas. So Daniel has already talked about the best practice database, and Rainer will talk about the HYBER tool, that is a best practice database of solutions, that is energy efficiency measures. So that is already covered, but we are missing the something that ties this together. So we have developed a handbook that is complementing the standard, and we call it EN 1688327 in practice. And it follows the standard and gives general guidance about all the steps. And it also contains additional information. And the idea here is to provide a common ground for interdisciplinary discussion, just as like the standard, but here we explain in more detail, for example, the definitions used in the standard, a bit more background information about energy efficiency in historic buildings. It is meant to inspire and point towards resources. So here we use the HYBER Atlas and the HYBER tool, and it includes checklists for the different steps and also success factors. And the intended audience of the handbook is professionals working in the field. So architects, engineers, heritage consultants, building surveyors, and professional property owners. So how is the handbook structured? Well, it follows the structure of the standard. So for all these 4 first steps here, it includes the additional information I mentioned. And that can be firstly text complementing the standard. That's like an interpretation of what the standard says. How can you put this into practice? It's a list of success factors. We have 2 hypothetical case studies in the handbook. One is called the library, and the other one is called the farmhouse. And there we discuss or give hypothetical examples of how the different steps are carried out. We also have the best practice solutions from the Hybrid tool. Of course, with links to the tool. We have further reading and resources, and that is also connected to a couple of fact sheets that we have developed within the project. And we also have the best practice examples from the Hybrid Atlas. So the overall idea with this handbook is a text complementing the standard. You're still supposed to use the standard, and you cannot just use the handbook and say that you're using the standard, because there is some overlap, but everything isn't covered in the handbook, so you still need to use the standard. But we think that this is a text that can provide a good common platform and provide inspiration to professionals working in different disciplines. So yeah, you can have a look at the handbook on your own. It's downloadable as a PDF on the Task 59 website. So thank you very much.
Thank you, Gustav, for your presentation on the handbook. We have so far 3 questions. The first question is, does energy performance, or the assessment of energy performance, include embodied energy?
Yeah, the standard mentions life cycle analysis, but that's a discussion that we have had within the project, because I think there has been a shift in focus since the standard was issued until now, where carbon has become more and more important as the most important criteria when it comes to green renovation instead of energy. So the standard measures life cycle analysis, but it is one of our suggestions that in a revised version it should be even more emphasized. And there, of course, embodied carbon is included.
Thank you. Second question is about involving other guidelines, and it's mentioned the WTA International, and I know the handbook was based on the European CEN standard or guidelines. So the whole approach of the handbook was related to that. But I also know that in the next presentation, some of the outcome there was based on the WTA international guidelines. So hopefully Rainer can say something about that in the next presentation. And then we have one more question for you, Gustav. How similar is EN 16883 to the ASHRAE guidelines 34? And they seem to have similar structure and weaknesses.
Yes, that's true. So they are rather similar, and they have also been recently developed. So I think there's been a lot of common ground there in the production of the standards.
Thank you. So we have no more questions so far. And should you come up with questions about previous presentations, there will be some time at the end to bring them up. So please continue to put questions in the chat. Now, the next presentation is by Rainer Pfluger from the Innsbruck University, and he will talk about HYBRTool for selecting conservation-compatible retrofit solutions. Rainer, the floor is yours.
Yeah, hello and welcome from Innsbruck, Austria. Thank you for the kind introduction, Thor. Yes, I will talk about the HYBRTool, and I would like to mention Alexander Riese, who did most of the work in this part. So it's all about selecting conservation-compatible retrofit solutions. I will present you the HYBRTool. We go through the systematics, and then at the end I will show you how it works in the online version. So for you as the audience, you might be interested in how to find appropriate solutions for your specific building. You want to bring together the preservation of the historic values. At the same time, you want to raise the living comfort and the energy efficiency of the building. And maybe you want to introduce solar energy, and all these together should be a synergy, not a contradiction. And there are a lot of solutions which you should find. And that's the reason why we looked for a kind of tool to make it more easy for you to find the proper solution for your specific buildings. Okay, it's always different from case to case, but other examples could be a good basis for further planning. So the question is how to find the appropriate solution. And therefore, the HYBRTool was programmed. It was partly initiated in the INTERREG Alpine Space Project, and with a lot of information from the IA consortium from the task 59. There was a lot of content and scientific expertise, and you will find this tool on the as a web-based tool under this link, and I will show you soon how it works in practice. So what were the criteria for us for collecting the technical solutions? They had to fulfill three criteria. They had, first of all, to be compatible with historic values, but they should solve the technical function, and they should have a certain or high energetic improvement. So these three criteria had to be fulfilled. Otherwise, if one criteria is not fulfilled, it was not part of the game. So then we had several questions on the solution. First of all, what is the solution about? That's what you want to know. What is it all about, and how does it work, and why does it work? So why does it work in terms of compatibility or historic value conservation? And how does it work in a technical and building physical point of view? And what is the energy improvement behind it? So, and the third thing is, it's not a solution completely separated from the building itself. It works well, but maybe only in one or the other context of the buildings. So what is special about the building and its surrounding? So, and then there is not one solution solving all and everything. Each of the solutions have some pros and cons. You should know about the positive things, but also on the problems and weak points of the solutions. That's what helps you for guiding in finding the right solution. If you have more time and look for further reading, you can read for publications. You will find links to publications and further information, web-based information with a click after you have selected your solutions. Yeah, as mentioned, it is a collaboration of the Alpine Space Project Atlas and the Task 59. There's a lot of knowledge of a wide-based group of experts. And now how to find your solution. We grouped it in the elements, though the most important building elements are the walls, the windows, and then the HVAC system, which consists of solar, ventilation, and heating, or maybe heating and cooling. Yeah? What is missing up to now is the roof part, but yeah, it's not an yeah, quite finalized project. Maybe in future also the roof part can be added, but walls, windows is the most important parts up to now, which is for the building envelope. And then the HVAC part is also represented. And as it's from the solar heating and cooling, the solar part is also rather important. So let's go through these categories and the building elements, starting with the walls. We collected around 40 solutions for the walls. How could you enhance them in terms of comfort, in terms of energy efficiency, in terms of better insulation? Mostly these solutions are for internal insulation because it's on historic buildings where the internal insulation is the most feasible one in most cases, but also external insulation may be a good solution in some specific projects. All technical possibilities from frame infill insulation, cavity insulation, reversible solutions, and other innovative solutions are in this collection. Nearly half of the solutions are assigned to internal insulation. As mentioned, this is one of the important solution in terms of historic buildings. Second, the windows. We have around 60 solutions. They are classified on the type of component, which is either single window or box type window or compound window. So you find your component in the list, and then you can search for solutions specifically. And then you get some questions about further distinction according to the historical impact. Is it possible to have impact from inside or outside or none of them? So you choose the right selection here and will be guided to a proper solution which fits for your building. We will do the example, the online example, especially on the windows, just to show you. I would like to mention more on this because we will have it on the screen in some minutes. And then the HVAC part, which is on heating and ventilation, in total 18 solutions for ventilation. By the way, this is one picture of a ventilation outlet of a farmhouse building on the roof, on the ceiling, which is a wooden panel. And this is the ventilation outlet. That's interesting just to mention one example. So for the heating, we had collected 25 solutions, which are divided in heat production and heat distribution. So what is the heat source and what is the heat sink? So is it done by radiators or floor heating or whatever? Yeah, and then last but not least, the solar part, around 40 solutions, mainly on building integrated PV. So where can you integrate photovoltaics in an historic building? It can be integrated in the roof, or mostly roof integrated. It could be attached to the wall, to the facade, but it always have to take respect on the historic value. And in some cases, it's not possible at all. Maybe on a listed building, it's even not allowed to do so, but you can have freestanding solar plants and solutions for the integration into this landscape. So both is possible, building integrated or freestanding, and you will find around 40 solutions about solar. Yeah, and now I'll explain to you shortly about the structure and the decision tree behind this tool. It should be simple to use and a quick pre-selection for your solutions. You don't have to read manuals to use this tool. It's very easy to use, very intuitive, and you can get information about the situation and the historic context. That's the decision tree behind. I don't want to go in detail. It's rather complicated behind, but the front end, what the user sees, is rather simple. So you should find your solution at the end, but within some mouse clicks. So how does it work for you, for the user? First, you choose your element. I already mentioned the elements, which are windows, walls, ventilation, solar, and heating. So one mouse click for the elements, yeah, and then you get some next question. For example, we do it in the example for the windows, and you are asked what is the current status and what is the impact and what are the constraints. So only 3 questions, and then you end up with a selection of solutions, which you can read. You can see if it's a good solution or maybe adapted to your situation. You get a PDF result, and that's really useful. You also get a link to the best practice Hyper Atlas, which Daniel already described. Already in the Hyper Atlas, you find some solutions, but it's a lot of work to search for solutions. And with this, with this tool, you can have a direct link back to the Hyper Atlas with one mouse click. We will see how it works in the example of Windows. So let's have a look. I hope you can see the tool now. There's a small description of the Hyper tool on the left-hand side. And then the before mentioned 4 categories, which are windows, walls, ventilation, and solar. So let's choose, as described, the windows. You press the button Start Tool, and you start with the first question. The question is, which kind of window do you want to refurbish or recreate? You see always some pictures, but also the text. In this time, you find 3 options, which is the box type window, the single window, or the coupled window. Let's choose, for example, the box type window. What can we do for this? And the next question is, which impact on the appearance is allowed? So you can change it from the inside or from the outside or nothing even. So even you have low impact or less impact as possible. So, and then you can have impact on the inside, or from the outside and outside and inside. And maybe it's possible to change even the whole window. You can replace it by a new one. Yeah, let's choose this impact on the appearance from the inside, for example. And then, yeah, you have some options. What can you do if you can change the appearance from the inside? Maybe you can replace the inner glass, or you can put an additional layer of glass from the inside, or you replace the sashes, adding some solar shading inside, whatever. Yeah, let's choose the addition of a layer of glass. In this way, we preserve the original window outside. From outside, there is no change at all. But we could enhance the situation from thermal point of view and comfort point of view. Let's have a look what could be done in this case. Yeah, so we put an additional layer of glass. We have the option to find here a PDF download with all the solution and its description. Let's click on it and we find the PDF. First of all, some pictures, and we get a description of the solution, what it's all about, and why it does work, and some pros and cons. And yeah, then some further information, some cross-section. Here you find the additional glass layer and the original structure outside. Yeah, and some pictures. In this case, it's from the example of the Osram building. Yeah, you get immediately some examples and a link. This is the link to the Hyber Atlas, where you can find more information of the complete building and of this specific solution where it's picked out in this tool. So let's go back to the to the tool itself. You can directly click on the link and you are directly in the building from Denmark, Copenhagen, the Osram building, where especially this solution, a new glass layer inside, was done, and the external shell was kept as in the original status. So the good thing is that you can learn more about the total building, about the holistic approach in this building. Maybe it's totally different from yours, but you can learn how the solution was implemented in this specific building. Yeah, and hopefully it's helpful for you, and at least it could be adapted to your to your specific solution. So to summarize, the Hyber tool will help you to find conservation-compatible retrofit solutions and will provide links to realized reference examples and best practice projects. The focus was on energy efficiency and solar energy for cultural heritage. So yeah, I hope you are interested in this tool. If you have some further questions, welcome. And that's my email address if you have further questions or want to contact me in future. Thank you.
Thank you very much, Rainer. We have two questions. The first one is the Hyber tool links through the Hyber Atlas best case examples. Does it also suggest technical applications that have not been included in Hyber Atlas?
Exactly. That's there are more solutions and more technical details, and there is not always a link also to the Hyber Atlas. So we had good solutions, but as Daniel mentioned, the Hyber Atlas is only on buildings where we had really a holistic approach. It's not only one solution and the rest may be done good or not. So the Hyber Atlas is focused on this holistic approach. But this tool is focused on the solutions, and maybe there are solutions which are worth to be published or to think about, but they are not in the Haber Atlas. So yes, the answer is yes. There's more than the examples in the Atlas. Yeah.
Thank you. Second question, not all solutions may be appropriate in all climate zones. How is climate, both current and future, taken into account in the tool?
Yes, there we have the advantage that the project Atlas and the project or the task 59 was rather international. And yeah, the question is completely right. Some solutions really only work in a specific context, but the context to the solutions is given in the documentation in the PDF. It's closely related, and also the restrictions are mentioned. This solution only works in this climate or under these boundary conditions, and in others not. That's important. We also have these pros and cons, and if there are limitations, they are also mentioned in the documentation. Yeah, that's really important. You have to look specifically on the climate. Most of the examples are from the Alpine regions, but the tool is more general and yeah, for different climates also. Yeah.
Thank you. Third question, which also relates to climate change. Do you also consider cooling measures in times of increasing temperature and heat waves?
Yes, it is, and that's also for cultural heritage. Often it's an important task, and it's not so easy. So the first step for having good summer comfort or good climate, indoor climate, under severe outer conditions in summer is shading. But yeah, you can do all and everything in modern new buildings with shading, but it's not so easy for historic buildings. But shading is an important element. And but there are different solutions tackling cooling or good indoor climate under summer conditions. Yes, and this was also tackled in the solutions. But always with close link to the historic value. So you can't use Venetian blinds, external shading on a historic buildings. You have to yeah, use solutions which are compatible with the historic value.
Thank you, Rainer, for the presentation and for answering the questions. I don't think we have any more questions for now. So let's move on to the last presentation. Roger Curtis, speaking from Edinburgh, Scotland, at Historic Environment Scotland, will talk about the research communication and dissemination of results within Task 59. The floor is yours, Roger.
Thank you, Tor, for the introduction and also the opportunity to speak to this group at the conclusion of the NZ project, as we've called it. So just check, can you see my opening slide, please?
Yes, we do.
Good, thank you. So one of the tasks, as was outlined, was the research communication and dissemination. So you heard about some of the extensive correlation of evidence and information on various platforms and through various mechanisms. And what was called subtask D, in its charismatic description, this task was led by Historic Environment Scotland, assisted by many others in the program as well, I must say. And by way of an outline, then we had a series of strands of activity that were mandated in the project as outputs and deliverables over the 4 years of the project. And the first one was really physical events, what you and I would call an in-person seminar. And they took different levels for homeowners, members of the public, for professionals, for architects, engineers, and those types, and also for the people who do the work, so the trades and the crafts who make things happen. And actually, it was quite interesting how easily you can get people to attend or not. Homeowners will generally come to something, and professionals, as part of their CPD programs, you can get to various sessions and lectures and presentations quite easily. But it's very hard to get tradespeople to attend. They're busy doing work for clients. Every day they're not working, they can't necessarily fee activity. So we found it was interesting in how to engage with the different sectors. And some of the results of these presentations are posted up on the website. A big part of it was, obviously, as you might expect, was blogs and online activity and various social media strands. We also put up quite a lot of material onto the TAS 59 website that has been mentioned a couple of times. The link is there as well. Firstly, to inform the public and other stakeholders and indeed partners during the project as to what has been happening, what has been learnt, various papers and other things that have been written. The website management and maintenance was done by the SHC program, so that was kept by them, which in fact worked very well. And a series of newsletters over the course of the project. So I will drop into some of these headings in a little more detail, so that you can perhaps get familiar with how to access this material, which is still available. And the website had various details of things on it through which you could access things. First of which was the touring exhibition, and I'll come to the details of that. Records of the online activity. So we once a blog had gone out, we made sure it was captured on the site for later reading by others. The records and the dates that went with that. Quite a bit of the program was concerned with dissemination of technical and scientific knowledge, and generally that was put out through academic papers and publications. So there is a section on the site for that. Twitter and blog records Twitter records were also uploaded. Also the past events that I've spoken of. So we had, let's say we had an event in Copenhagen. The results of that event and some of the learning material were put there. And also the two accessible outputs, the Hyper Atlas and the Hyper Tool, that you've heard about, are also accessed via links on the project website itself. The touring exhibition then, one of the outputs, this essentially was a series of 10 pull-up panels, and it would cover various case studies that were delivered over the project region. It was designed to be an entry feature for events of various types in all parts of the project areas, as a sort of visual and physical headline catching for attendees, prompting questions, prompting ideas, and getting a feeling for the nature of the materials and the interventions that were being done on the historic buildings that were being discussed and also put up on the Hyper Atlas. As I said, it consisted of 10 pull-up panels, and it doesn't sound much, but you try packing those up and moving them around. It's surprising how much how much space it takes. And I'd like to emphasize that these panels, which are still available, can be booked by the EURAC Research Office, and they'll send them onto your institution or organization as part of an exhibition. And the only catch is that you have to pay the postage either back home, back to EURAC, or onto the next place. So this did well during the early days of the project, and you'll appreciate as soon as COVID kicked in from sort of February, March 2020, things went a bit quiet on that one. So keen to give those panels an outing. It's also internet proof, it's low energy, and it's free, and it won't stop working as long as people could see it. that's what it looks like. That's 1, 2, 3, 4, 5 of the panels. Quite, you need a good line of wall to put them up. That's in our facility, our training facility up in Stirling, just to the west of Edinburgh in Scotland. And as you can see, quite a nice, clear delivery, good visuals, quick way of getting a feeling for what the measures were in certain places. And then you could catch up with a bit more detail on the Hyber Atlas, for example. This is a screen grab of the touring exhibition page on the website, which allows you to get hold of it, and more importantly, look at the calendar and see where it may be lying just now, and an option for getting hold of it for yourself. I mentioned blog records, and you're seeing a little list of headings there and some details, which obviously a live link to a little bit more information behind all of those headings. There's actually 3 or 4 lines of this particular entry. I've just shown you one. Here's the second one. Lots of interesting material that has been summarized. No accident that the Hess entry there is at the top on that one. So that's the blog record. You'll see the taskbar, task59.iea-shc.org is the key one you're aiming for, with the /blog to get you there. I also mentioned scientific publications, slightly more formal material, not always bedtime reading, but certainly some of the more strongly evidenced scientific material that fell out of the project in various disciplines to do with a number of factors, photovoltaic, thermal risk, and other things to do with the retrofit work that we were showcasing. Again, some more there, whole range of different titles, so they're not necessarily one particular format, and even a couple of presentations have got on there, and you'll recognize some of the Elsevier and other academic publication houses there. Twitter and Facebook seem to work reasonably well. I think the Twitter was probably the main one that Hess ran with. And again, just drawing quick and sharp attention to various projects, specifically when we had new case studies uploaded to the Hyber Atlas. This was a way of routing people to some new information that was up there, get a quick sniff of it, and then get into the detail by going on to into the Hyber Atlas and finding out what happened in more detail, as Daniel outlined earlier. And you'll recognize the logo in the top of each of these as a way of keeping the branding consistent. I mentioned events and things and various ways you can access learning materials and other products from events all over the region, all over certainly Northwestern Europe particularly, and indeed other countries. So you can see Bolzano, various sites in Italy, some virtual events later on as things had to change, but also parts of Scandinavia as well. The content of what's here varies, but normally there will be a record of the PowerPoint and some of the materials, as well as some of the administrative information that went with that. You'll be familiar with the actual Hyber Atlas now. You've had plenty of introductions, but so you'll know what that looks like and how you get there. And ditto, same again for the Hyber tool. So my team back in Edinburgh were able to add content to the site and make basic adjustments, but for some of these bigger sections like the Hyber tool and the Hyber Atlas, action and activity there was reserved with the SHC web managers, and that was quite a good way of stopping us breaking the tool and other things on the site, but it did allow us to do basic uploading and adjustments. And more recently, we've just put up the reports from the overall project, which came through a couple of days ago from Alexandra. In terms of legacy, we know from experience with many projects that when the project stops, the administration and the funding quite often dries up on the website, and essentially that knowledge is no longer available, or even worse, sometimes lost. So one of the good things with this is that facility is kept running by the SHC. The administration continues. It'll stay there. It has an ongoing life, particularly with the Hyber Atlas and the Hyber tool. And the social media activity is going to be taken forward by one of the ICOMOS scientific committees, of which Franziska Haas, who was with the project, is kindly taking forward. But Hess is able to support every now and then with some social media inputs, partly because we picked up quite a bit of experience in doing it during our time on the project. So that's my main sort of dissemination type details. I'll be interested in how the audience, if audience experienced any of those outputs or indeed experience from your own projects. And just finally then, just to blast the trumpet for Hess as well, a couple of links to our own sites and publications and my email there at the bottom if you want to catch up after this session. So I'll probably stop there, and happy to take any questions and things. I do have to run out the door just before the finish time, as my dog needs to go to the vet. But that's I hope that's good for now.
Thank you, Roger. As of now, we don't have any questions relating specifically to your presentation. They may still come. And also to the audience, this is a good time to put forward any questions that you've been thinking about during the presentations, and also if you have any comments. And here we have a question and a comment. It says, "Congratulations for the excellent work. It will be an important information for the EU OMC group on climate change and cultural heritage. Overall question, did any of the retrofit measures calculate the CO2 produced and after completion, how much CO2 will be saved in the future?"
I can comment on that from one particular element. So yes, no, good question, because actually these measures are all about carbon, reducing operational carbon, and indeed the question of embodied carbon, which, as was indicated by Gustav, that area of concern matured over the project, and I think it's quite a current issue now. It wasn't quite in the forefront. Most national tools for conforming with the Energy Performance Directive obliges the system to do a calculation on CO2 saved. So in the UK, the Energy Performance Certificate will give you carbon saved as a result of a series of measures. And certainly for the projects that we put up on the Hyber Atlas, there will be the EPC rating. It probably, and that gives the CO2 before and after the measures. I'm not sure what other jurisdictions have, but I suspect it's very similar, because it's all about complying with a common European standard for performance of buildings. And I suspect that the granularity and the detail needed on this will increase as we start to get into the real hard detail of energy. But that's probably enough from me. Perhaps others on the panel would like to comment.
Yes, this is a broad question. So would anybody else like to comment here?
As Roger said, the topic became increasingly used. I think the cases we documented seldomly looked at the carbon CO2 emissions of the measures. I know for sure that it was one of the Vorarlberg cases which had a complete life cycle balance with regards to CO2. Don't know, Daniel, whether you remember the name. I can check it up afterwards, but I have to say that it is not very many. There are some who have included it. Reinhard, do you have others in mind?
Yeah, there are two case studies where it was evaluated in detail, but we could say in brief is that the most important CO2 emissions of the buildings are throughout the lifetime, throughout the use by heating, yeah? And more or less negligible part is in the embedded energy. So first of all, the energy efficiency measures, which is insulation and reduction of heating, is the most part of the CO2 emissions, and a very, very small part is the construction, especially in refurbishing and historic buildings, because the structure is already there and it's not demolished. So we keep the structure. We don't need additional concrete or steel or whatever with a high embedded energy. We only add some insulation, and the content gray energy in the insulation is rather small, but the effect is great. The effect in the period of time of use and the heating or cooling need, if it is reduced, that's the biggest reduction of CO2 emissions. That was the outcome. And
second question, will there be any intent to link the HYBRITOOL output technologies to the EBC research on in-building energy use, so that we can see applicable research in what CO2 can be saved by implemented any given method? So who would like to answer that?
Not sure if I could do that, but it's a fair question.
I think it relates to the HYBRITOOL. Would you like to start, Rainer?
Yeah, the problem is that the HYBRITOOL only gives solutions on a technical point of view, and does some assessment in terms of compatibility in historic structures. But then the outcome in terms of CO2 emissions depends on the application where you use this solution. So you need an energy balance calculation, and as we had before in the discussion, it's a procedure over time. Most of the refurbishing process is not done in one step, but in a step-by-step procedure. So maybe it takes several years till the next step will be performed. But you can calculate it this over the time. But then you need an energy balance calculation behind it, and you need it specifically on your building. The tool itself, the HYBRITOOL itself, cannot give this information, because it's only about what solution, how does it work, and is it compatible or not, or is it useful in your case or not. But it's not a quantitative output.
Gustav, would you like to add something to that?
Yeah, I just have a general point regarding greenhouse gases in relation to energy use. A very nice thing with energy use is that you can easily measure it in most cases, but when it comes to carbon, it's much more complicated and you rely on models. So it's good as an indicator, but it's much more difficult to treat.
I might find a big comment. Could you mute? I will present the final results also at the EBC Exco meeting. So I can bring forward the idea. I admit that I'm not so much aware which specific annex, they call it in EBC, you might have had in mind. Maybe we can exchange. If you are specifically working in one of the annexes, could also be you to make up the link. So we would definitely be interested in having it being used further, be it the HYBRITOOL or being the HYBRATLAS.
So,
Roger, go ahead.
Yes, thank you, Tor. Just to add, for one of our case studies that we've put up on the HYBRATLAS Hollywood Park Lodge, we'll be doing embodied carbon calculations and workings for the measures that we've put in and linking that with operational carbon savings, but also looking at benefits of what was referred to in the new European Bauhaus objective of grown materials or natural materials, and seeing how that contributes to embedding carbon or capturing carbon. So in the retrofit, you're saving operational carbon, as Rainer mentioned, but you're also to some degree capturing an element in its creation of that material. So we'll be trying to put some numbers on that over the next year and a half or so, and we'll see where that goes. It's early days, and I freely admit we haven't got a full picture, but should have something quite soon.
Would
Thank
be great if you update then the Hyper Atlas, because finally we have inserted the field where to document this. It has just not been used by that many. Would be nice to have it.
Yes, no, good idea. We'll aim for that.
Thank you for answering those questions. I think it's sort of getting into the final stage of the webinar. Before we say goodbye, Alexandra, would you like to say something of in what direction we might be heading after this project?
Well, I think a lot of streets are open. Yeah, what I feel is that what we did with Task 59 is bring together a lot of knowledge, make a start, make an infrastructure available, which we hope will be used further. So you're very welcome to feed into the Hyper Atlas. As a person, as an architect, as a building owner, but I imagine that also researchers are in the audience. So in upcoming projects, if you think about a tool where you document the case studies, think about including the Hyper Atlas. It's also, from its concept, multilingual. It might be adapted to local needs, but I think would be a big benefit for all projects if we do not have different databases, but just collect in one and use the synergies. Also, the hybrid tool finally is something which you imagine very well could be adapted to local situations, could be solutions from other contexts can be added, can be enhanced. The guideline, I think, will also grow, I imagine. The standard is now some years old. It might come the point where we have to relook at it, to revise it. And I think everything you might be interested to contribute is really welcome. One thing I just point out, we started well with the traveling exhibition, as Roger pointed out. Then COVID came. It is all in my office. If any of you has an event on energy, on historic buildings, where you think a visual presentation could trigger interest of people, could be a starting point for discussion, could engage people, book it. The typical way would be that we send it and you send it to the next user. So that would be a very, very easy way to have to have it traveling again, our exhibition.
Thank you, Alexandra. I haven't seen any more questions, so I think it's time to conclude this webinar. I'd like to thank the speakers. You've set a good example by keeping the timetable, and you came well prepared. I would also like to thank my colleague Annie Nyström, who's been in charge of the administration around this webinar, and thanks to her, everything has worked well. And we also have another person who's very important as our producer, Andreas from the company AppinConf. I know Andreas can hear us, and I'd like to thank you very much for having carried this out in a very nice and seamless way. Those of you who have tried to manage big Zoom meetings by themselves now know how nerve-wracking it can be. So thank you for helping us with the production. Last but not least, I'd like to thank the audience. We gathered more than 100 participants, which I think is really good. The webinar forum, I think, is a good way to present results. It works almost as fine as if we met in real life. And frankly, most of you would not have been able to attend a physical meeting, and certainly not a 2-hour meeting. So it's a good way to reach out. The discussions in a technical way work fine, but we don't get the dynamics. I could see that there were several topics where the whole panel could have been involved, and we could have had a good exchange with the audience. But we will have to save that. But finally, a personal reflection is that even though this works, I looked at the list of participants, the people who are listening, and I see a lot of dear friends and colleagues. And if this had been in real life, this is now when the most important part of the webinar started. That would be the post-seminar, when we got together over a cup of coffee or a beer or whatever, and had and solved the real world problems. So on behalf of the speakers and the whole project, I'd like to say that we miss you, and sooner or later we will meet in real life. So that's it for task 59. And keep in mind or remember to visit the webpage, task59.iea/shc.org. That's my finishing words. Thank you.